Hi everyone. Math can be super fun, and today we are proving it with the magic hexagon. Struggling to remember a ton of trigonometric formulas like reciprocals or quotient identities? No worries. I'm going to show you a cool trick that makes learning these formulas easy and exciting. Let's jump in and see how it works. So this is the magic hexagon. So each corner of the hexagon represents one of the six functions, and there are three diagonals to it. So each corner is represented with one trigonometric identity. Let's start with sine, cos, tan, cot, secant, and cosecant. These are arranged into a neat hexagon shape. It's like a cheat sheet for remembering trigonometric identities. Let's see why this is so powerful. Let's start with the reciprocal identities. These are super simple with the magic hexagon. Each trigonometric function has a reciprocal partner directly opposite on the hexagon. Let's talk one diagonal. Sine and cos are reciprocal to each other. That means sine theta is equal to 1 by cosecant theta and cosecant theta is equal to 1 by sine theta. As simple as that. Let's move on to the next diagonal. Cos and secant are reciprocal to each other, and similarly the next diagonal, cot and tan are reciprocal to each other. That's how we derive the reciprocal identities using this magic hexagon through the diagonals. And moving on to the next one, let's see Pythagorean identities. So there are three inverted triangles here. Using this inverted triangle, the ratios that are there in the three corners of the triangle, you can derive these Pythagorean identities. Let's take this triangle. Sine and cos are there in the top two vertices. Let's add these two by squaring it. Sine square theta plus cos square theta, you will get the value that is there in third vertex. Similarly, tan square theta plus 1 is equal to secant square theta, and third one is 1 plus cot square theta is equal to cosecant square theta. This is how you formulate the Pythagorean identities using magic hexagon. The next one is the complementary ratios. So here, if you see that the three ratios that are on the right hand side are complementary ratios to the ones that are available on the left hand side. Cosecant is a complementary for sine, and similarly cot is the complementary for the tan theta. So cot is represented as cotangent. Similarly, the third pair is cosecant and secant. Cosecant is a complementary ratio for the secant. So this is how you derive the complementary ratios by navigating horizontally. And moving on to the actual ratios of the trigonometric functions, we'll again use the diagonal methodology to derive that. So for that, we'll start representing or marking the diagonals as O stands for opposite side, A for adjacent side, H for hypotenuse. When you take one diagonal and you need to start with one end of the diagonal, you will get the ratio formula for that particular ratio, trigonometric ratio. That is sine theta is equal to opposite divided by hypotenuse. Similarly, cosecant theta is equal to hypotenuse divided by opposite side. And moving on to the next diagonal, you will get cos theta is equal to adjacent divided by hypotenuse, and secant theta is equal to hypotenuse divided by adjacent side. And similarly, you take the third diagonal, you will get cot theta is equal to adjacent divided by opposite side. And starting with the tan theta is equal to opposite side by adjacent side. This is how you derive the formulas for the co-trigonometric functions from the sides of a triangle. And moving on to the other ones, you can still get the various relationships between the ratios by navigating through the vertices in the clockwise direction as well as the anti-clockwise direction. Let's start with the clockwise direction. So when you start from any ratio. Let's take an example of tan. So you navigate in the clockwise direction. So you will get the relationship between the relationship function here. So tan theta is equal to sin theta divided by cos theta. Similarly, you start from the sin theta is equal to cos theta divided by cot theta. So you will take the next two neighbors to get the ratio. Okay. Similarly, you take the let's navigate in the anti-clockwise direction. Let's start with the cot theta. So navigate through the neighbors in the anti-clockwise direction. So cot theta is equal to cos theta divided by sin theta. And similarly, cos theta is equal to sin theta divided by tan theta. Similarly, you can navigate through the hexagon vertices in clockwise direction and anti-clockwise direction. You will get six relationship ratios in each direction. And that's a magic hexagon. It's a simple visual way to master trigonometric identities without memorizing a ton of formulas. Next time you are stuck on a trigonometric problem, just picture this hexagon in your mind and you will be able to formulate any trigonometric ratios. Thank you very much.